Algebra 2. Today, one learning target is on I can divide complex numbers, and the strategy you're going to use for this type of problem. First of all, never leave I, the imaginary number symbol, in the denominator or the bottom of a fraction or division problem. Make sure you never give me an answer where I is in the bottom of the division problem or answer. Secondly, you're going to rationalize. Rationalize is a math word meaning that you're going to figure out a way mathematically to get rid of the I off the bottom of the problem. Rationalize the denominator. You're going to do that by multiplying both the top and the bottom by I, or what's called the conjugate. And I'll go over this word with you in just a second. So it really depends on the type of question that you see. So like first example, notice that I have 10 divided by I, and since we know from the past that I stands for the square root of -1, then this I stands for that. We can't leave a radical in the denominator of a fraction problem or division problem, so because I stands for that, that's the reason we have to follow this rule. So we always have to make sure that the I is gone. To do that, you're going to rationalize, which in this case means if there's only one term here, all you ever have to do, put a times sign out to the side, you're going to multiply the top and the bottom by I. And this is what the first step will look like. You'll go to the side. And the reason this works mathematically is because I divided by itself is essentially 1. Anything divided by itself is 1. And when I multiply any problem by 1, this is just a fancy way of writing 1, anytime I multiply a problem times 1, the answer is the same thing. It's the problem. And so even though it looks like I'm changing the way this problem looks, I'm actually using a little math trick here. I'm multiplying by 1. This is a fancy way of multiplying by 1, but that's going to allow me to get the I off the bottom. Because these are not equations, please don't write equal here. You're just going to show your work underneath. So we'll go underneath for the next step. To multiply fractions, you go straight across. So you're going to do 10 times I. You're going to drop that down. Then bring down your division bar. And then I times I, remember the power here is 1. So when you're multiplying, you always add powers. So you're going to get I to the second on the bottom. In the next step, you're going to have 10I. And you're always going to change I squared over. So we're going to change that to a -1. And then the last thing I need you to do, especially if the bottom number is a negative number, never leave that negative number on the bottom. We always want to simplify. And so you're going to divide 10 divided by -1. And so the best answer for this problem is going to be -10I. Okay, let's take a look at question 2. Notice in number 2 that the numerator this time has a complex number, whereas in example 1, the numerator only had a real number. Also notice in example 2 that the denominator is just an imaginary number, 3I. Because this is one single term, you are going to get rid of the I. You're going to rationalize the denominator by multiplying both the top and bottom by I. So again, just to repeat, anytime you have a problem where there's a single one term on the bottom, if it contains an I, of course, you're going to multiply the top and the bottom by that same value. And remember, this is just a different way to write 1. So I'm not really changing the problem, even though it looks like I am. My suggestion is when there's 2 terms on top that you kind of include those in parentheses because you're going to have to now multiply I times both of those. So you're using distributive property. So let's look at the numerator. 9 times I would be 9I. Positive 3I times I is going to be a positive 3I squared. Denominator, 3 times 1 is 3, and I times I is I squared. Okay, next step, every time you see an I squared, you're going to change it over. So the numerator becomes 9I plus 3 times, and this is going to be a negative 1. Notice in the denominator the same thing's happening. You have 3 times negative 1. Okay, this is not simplified, so we have to keep going. So now we're going to drop our 9I down. Nothing else we can do there. You are going to multiply 3 times negative 1. That's going to give you a negative 3. In the denominator of this division problem, you have 3 times negative 1. That's also going to give you a negative 3. And again, because I'm dealing with a binomial on top, 2 terms divided by a single term, please notice right now that there is no I on the bottom. But I do, however, have a negative, so I do not say that this is my final answer. What you're going to need to do is do what you've learned in Algebra 1. When you have 2 terms on top and 1 on the bottom, you actually can split it up into 2 fractions. And that's what I'm going to try to do here. Okay, so I'm going to have you visualize this as 9I divided by negative 3. And then this fraction is negative 3 divided by negative 3. And then I want you to simplify that. Okay, so you simplify until you cannot go any further. 9I divided by negative 3. Again, we don't leave this because it's negative. 9 divided by negative 3 is just negative 3. And then you drop your I term down. And then this division problem is negative 3 divided by itself, and that's going to be a positive 1. And here's my imaginary part. Here's my real part. It's a complex number. It is simplified now. And that's as far as I can go for example 2. But notice that this one took me a lot more time than number 1, and that's because there were an extra term on top. But those are the steps that you need to show. Please remember you're working down the page, not from left to right, so do not write equal signs. Please. Okay, let's look at example 3. In example 3, I want you to notice again, I have a complex number. Here's my real part and imaginary part. I'm going to go ahead and put parentheses around it. In the denominator, I see the same thing. I have a complex number. So I have 2 terms on top and 2 terms on the bottom. I cannot leave this I in the denominator of this problem. So what I have to do is rationalize. Now there's 2 different scenarios here. You either have to multiply by I, which is what I've done on example 1 and 2, or what's called the conjugate. So I told you I'd come back to that word and explain. Conjugate is only going to be used when you have a complex number on the bottom, or 2 terms. In order for you to get rid of this imaginary number, you have to multiply by the conjugate. The conjugate is the opposite sign in the middle. Okay, so I'm going to just type that to the side here. Use the opposite sign in the middle. Okay, so what I mean by that, making sure that you understand the language I used, is you're going to look at this, 3 plus 4i, and you're going to multiply by 3 minus 4i. So 3 minus 4i is the conjugate of this term, of these terms. Use the opposite sign in the middle. So if this is plus, use a minus, and vice versa. Remember, we're trying to do mathematically get rid of the I. So you're going to multiply by the conjugate. Whatever you put on the bottom, you must put the same thing on top. Okay, remember, third time today, that when you do that, this part that I am highlighting right now, this part is exactly the same thing as 1. Anything divided by itself is 1. Multiplying 1 by any problem is not going to change the problem. Now, yes, it's going to look entirely different, but it's not going to change the value. Alright, so, saying that, let's go forward in this problem, and you're going to have to do, it's multiplying by fractions, fraction times fraction. The rule is you're going to go straight across. Let me put my times sign back in here, and so I would use parentheses around this just because it has 2 terms. Let's focus in the numerator right now. So I want you to multiply this times this. And we're going to do that by using the FOIL method from the past. First, 5 times 3, 15. Outside, 5 times negative 4i, negative 20i. Inside, negative 2i times 3, negative 6i. And last, negative 2i times negative 4i, and that's going to be a positive 8i, and it's squared. Okay, so we've done FOIL on the top. Now your focus needs to go to the bottom. You have a binomial times a binomial again. So we're back to FOIL method. 3 times 3, 9. 3 times negative 4i is negative 12i. Inside terms, 4i times 3 is positive 12i. And last, 4i times negative 4i, and that's going to be a negative 16i squared. Okay, again, notice I didn't use an equal sign. I just showed my work below. Draw your big division bar. Now I need you to focus in the numerator. Notice that these 2 terms are like terms. Also notice there's an I squared that's showing up here, so we need to change that to a negative 1. We're going to go ahead and drop our 15 down. Just do one thing at a time here. Let's combine negative 20i minus 6i. We are in add mode right now. We're finished with FOIL, so we're done with the multiplication. We're going to do negative 20 minus 6, which is negative 26. And we're in add mode, so you're just going to drop your I down. Okay. Then you're going to say this is 8. This is a positive 8. Change I squared over to negative 1. Make it look like that. Denominator, you're going to drop your 9 down. You're going to notice that the inside terms, the middle, are the same terms. One's a negative, one's a positive though. So we're going to go ahead and combine. Negative 12 plus 12 is 0, so there's 0i left. If there's 0i, there is no use in writing it. Then you're going to grab your minus sign. Please notice that says minus 16, so minus 16 comes down, and you're going to immediately change the I squared part over to a negative 1. Okay. Next step, we draw a brick division bar. We go back to the top. We're looking for anything we can simplify. And so this term and this term, after I multiply, are just real numbers. So let's put them together. So you're going to call that 15 minus 8, which is 7. You're going to drop your imaginary part down, which is negative 26i. Okay, now you're going to go to the denominator, and I see a 9. Then I see a negative 16 times a negative 1. We're in multiply mode here because of the parentheses, of course. Negative times negative is positive, so please be careful on your sign rules. 16 times 1 is 16. Alright, numerator, I cannot do anything else to simplify. Okay, so I copy it down. Denominator, I have 2 real numbers, so they definitely need to be combined. 9 plus 16 is 25. Okay, make sure you notice the denominator now does not have an I. That is good. That's what we want to happen. Also notice that this number is not negative. That is also good. So right now I know, because of those two things that I just mentioned, that this is the simplified answer. That is the best answer for that problem. And remember, we're learning division today, so we could say this is the quotient of this problem. This is the quotient. When you hear me say the word conjugate, I'm asking you to change the sign of the middle and then just make sure that you multiply both top and bottom by that complex number. Okay, let me erase this and leave myself room for number 4. Please notice on number 4 right now we have a 1 term on top and we have 2 terms on the bottom. Because this is a complex number or a binomial, I know that in order for me to get rid of the I have to multiply by the conjugate. Conjugate is changing the sign in the middle. You will never bother the sign in front, okay, just this one. So your conjugate of 2 minus 5i would be 2 plus 5i. Whatever you put on the bottom of the fraction, you must do the same thing on top. Just to repeat, 4th time today, this must match this because this is essentially a fancy way of writing 1. Okay, I would use parentheses every time I wrote down a binomial. And to show the first step, I have this 1 term I need to distribute. 8i times 2, that would be 16i. 8i times 5i, that would be 8 times 5 is 40. And then I would do an I squared. Denominator, I see 2 by 2. So that's a binomial times binomial. I would do FOIL. First, outer, inner, last. 2 times 2 is 4. Outside, 2 times 5i is 10i. Inside, negative 5i times 2, negative 10i. And then negative 5i times positive 5i. Negative times positive is negative. 5 times 5 is 25. I times I is I squared. Okay, next step. Go to the top. Change this over to a negative 1. So it's going to be 16i plus 40 times negative 1. And we'll simplify that in a second. You'll go to the bottom and you notice that the middle terms are the same. One's positive 10 and one's negative 10, and that's essentially because we use the conjugate. That's why this method works. It's always going to cancel these out, but you still have to go through the steps to show. 10 minus 10 is 0. I don't have to write it down. I'm going to drop my first number down, which is 4. I'm going to drop my negative, that's a negative 25, and replace I squared with negative 1. Back to the top. We multiply 40 times negative 1. So we're going to get 16i minus 40. Obviously these are not like terms, so we can't do anything else on top. We go to the denominator, and we notice this part, multiplication always comes before addition. We have 4, and then we have a negative 25 times a negative 1. Negative times negative, I'm going to drop my 4 down, sorry. And then negative times negative is positive, and 25 times 1 is 25. And then the last thing I do is just make sure that I do combine the denominators. So I'm going to get 16i minus 40, and then on the bottom it's going to be 29. Again, pointing out hopefully the obvious. There's not an I on the bottom. That is what we want to happen. I do like that this is a positive number. We can leave a positive number in the final answer on the bottom. So that's as far as I have to go. Okay, so remember, if you have a question, like let's say you ended up getting maybe this type of answer, I will not accept that answer because it's not simplified. You are going to have to write it down into separate fractions. So like 4 over negative 2, and then negative 3i divided by negative 2, and then simplify. 4 divided by that would be negative 2. A negative divided by negative is a positive. That'll change over to plus 3i over 2. Okay, this part is a much better answer. Sorry about that, that's supposed to be a 2. This is a much better answer than this one. Okay, so be really careful on those. Okay, so that's how you divide complex numbers. You'll either have to multiply by I if there's a single term, like example 1 and example 2, or you'll have to multiply by a conjugate if it's like example 3 or 4 where you have 2 terms on the bottom. Alright, last, how do we solve quadratic equations with imaginary solutions? Now you guys have already had quadratic formula. I'm just here to remind you of a comment I made earlier. I told you we would come back to. So when we're using quadratic formula to determine the solutions of a problem, if the discriminant, which is the part underneath the radical, turns out to be a negative number, then that means you're going to expect 2 imaginary solutions. Okay, so I'm going to model to you what's going to happen here. Let's say we have a quadratic equation, 3x squared minus 1x plus 2 equals 0. Remember from the past, quadratic equations must be in that order, and it must be set equal to 0. You're going to jot down your A, your B, and your C. Okay. Then after you do that, you're going to write down the formula, which is x is equal to so the formula is x equals negative b plus or minus square root of b squared minus 4 AC, and you're going to divide that all by 2a. Okay, and we've had this in the past, so you know the drill. Alright, so let's see what happens here. I've got to find the answer for x. I do the opposite of b, so that's negative 1. I'm going to do plus minus. I'm going to do the square root of negative 1 in parentheses squared, and then minus a 4 times 3 times 2 and then it's all divided by 2 times 3. Okay, so here it's going to be a positive 1 plus or minus square root of, then we're going to do power, so negative 1 squared is positive 1, and then minus sign, and then you're going to multiply 4 times 3 times 2. 4 times 3 is 12, and 12 times 2 is 24. Okay, and then denominator, 2 times 3 is 6. Alright, we are going to continue working on the discriminant. Again, remember that word means the number underneath the radical. We do need to simplify, of course. 1 minus 24, and that becomes a negative 23. So the discriminant is a negative number. In the past, we would not have known what to do here, because if you type this in your calculator is going to say error. But now, since we're learning how to do imaginary numbers, we know that there actually is an answer to this. It just is imaginary. There's actually 2 answers. So here's what I want you to do after this. You're now going to do what you've learned in the past. You're now going to take the discriminant. You're going to take this part I've highlighted. You're going to write it a different way. You're now going to write the square root of negative 1 times 23. Okay, we know that this piece is what the square root of -1 is the definition of I. That's the whole purpose in this unit, is to understand where that came from. And so we're going to drop our 1 down, our plus minus symbol. 23 is not divisible by a perfect square. 4 does not go into it, 9, 16, all that. So 23 is just going to have to stay underneath the radical. But the part I've circled in yellow, we know now is an imaginary number. So that I comes outside the radical. And we have a real number here, plus minus, we have an imaginary number here. We cannot add an imaginary number to a real number, so the top simplified. The bottom of this division problem or fraction is a positive 6, and a positive 6 is simplified. And so I just have to circle it, and that would be my best answer to that problem. 1 plus or minus I radical 23 divided by 6. Okay, and I'm going to stop there, but I want you to remember that the reason that we went back through this is because we had not gone and learned what to do with a negative underneath the radical. So you will have some questions like this. Just be aware that I do want you from here to always simplify and give me an I answer when you can. Okay, so we'll give that a try. 2 learning targets today. I can divide complex numbers, and now I can solve quadratic equations that have imaginary solutions.